Hi, welcome to the Ghostcast, the official podcast of the Ghostlab. The Ghostlab is an interdisciplinary lab at the College of Arts, Media, and Design at Northeastern University. We leverage design, engineering, computer science, and social science to address societal challenges through creative technologies such as games and virtual reality. In the Ghostcast, we discuss hot topics in society and the work we do at Ghostlab on those topics. We will feature members of our lab, but also special guests. And while we do that, we like to have a bit of fun together. In our first ever episode, 4 members of the lab, Feyyaz Sonbudak, Aubrey Simonson, Erica Kleinman, and Giovanni Troiano, discuss the work that Ghostlab will be presenting at the 2025 CHI Conference in Yokohama, Japan. The CHI Conference is the most prestigious conference in the world for the field of human-computer interaction. Ghostlab members will present 3 full papers and 2 late-breaking work papers covering research on esports, escape rooms, computational thinking, and virtual reality.
So in this first episode, we would like to talk about CHI and why CHI is important. And we have some folks sending papers there, publishing there, and we will listen to their papers and what's about and talk about them. So first, Giovanni, let's introduce you to the listeners.
Oh, yeah, sure. My name is Giovanni Troiano. I am obviously from Italy, original Italian, not like a lot of American people that I meet, like, I'm Italian too. Like, yeah, sure. Were you born in Italy? No, I was born in Detroit. Like, well, you're not really Italian. Yeah, but my grandfather was Italian. Yeah, okay, sure. I guess that makes you Italian too. No, but I'm originally from Italy, from the south of Italy, from Naples, the city of sun, pizza, right? And good food, I guess. And I am a second-year assistant research professor at Northeastern University, working with Kasper Hartweld. We co-direct the Ghostlab, which is generously sponsoring this Ghostcast. Ergo, the name Ghostcast, right? Because it comes from the Ghostlab. But so my expertise is in computational thinking, which I will not talk about right now. I will talk about later when I introduce my CHI papers. And in the context of computational thinking and game-based learning, which is primarily the area of application where I use computational thinking, measurement and metrics, I focus especially on measuring how students develop in their computational thinking as they design games, for example, in Scratch.
Yeah. Okay, let's go with Aubrey.
Yeah. Hi, I'm Aubrey. I'm a second-year PhD student, also in the Ghostlab. I study primarily virtual reality, and I study virtual reality from an HCI, or a human-computer interaction perspective.
Nice. And last but not, Erica.
I'm Erica. I am a second-year postdoctoral research associate in the Ghostlab, and I do a lot of work around learning and sort of metacognitive aspects of learning and self-regulated learning in games. And I especially study this in the context of esports, so we can learn how to sort of leverage gamified technology or technology in general to help people learn to perform tasks.
So why CHI is important?
I guess because it is. I mean, it's an important conference because it's, first of all, it's when you think about CHI, you're thinking about really the top tier conference in human-computer interaction, right? Or technically speaking, it's a conference on human factors in computing systems. Am I correct? Yeah, that's what they call it. So it's an important conference because it brings together so many different perspectives and disciplines that intersect and speak to the concept of human-computer interaction. So, for example, at CHI, you can find papers where people interact with computers in the health research domain or application domain. Or you can have papers that are specifically about games, right? Or you can have papers that are more specifically about how people use technology to interact through social media. You have papers that are political, where they people talk about political activism through the use of technology, social media, interactive technologies for the most part. So it's an interesting blend of different interdisciplinary, how would you say, approaches to research that you don't really find in other conferences. So that's, I think, what makes CHI unique.
Okay, let's go back to Erica. She's about to publish 2 papers in Kai in this conference, and I would like to ask you about the first one, the escape room. Can you give us a little bit information?
Yeah, so this paper obviously is not related to esports, though if you ask me, escape rooms would make great esports. We should make that a thing.
How about the title of the paper?
Oh yeah, it's called From Locked Rooms to Open Minds. Escape room best practices to enhance reflection in extended reality learning environments, which I actually think is one of the best titles I've ever had on a
It's the right
paper.
title.
The rankings are tough because I do have a paper called Naked and on Fire. So like that's probably the best. And it's not my like I'm not the first author on that paper, someone else is, but like
Okay.
Wait, hang on. How did you get away with that? What is that paper about?
it's about narrative agency in games. And somebody, like one of the people we talked to, it's an interview paper, and one of the people we interviewed literally said that a game had lower agency because it wasn't like Breath of the Wild where you could fight Ganon naked and on fire if you wanted to. So we literally just took that part of the quote and put it in the title. And it's fantastic. So,
Well-
you know, whenever I go like, this is like one of the best titles I've ever had on a paper, it's ranked below that one.
Okay, understandable. This makes sense.
It
Please
was a Kai
continue.
paper too. It was a Kai paper from like
We need to do
2021.
another podcast to talk about that paper specifically.
We can like bring in the first author as a guest. It'd be funny.
Yeah.
I'm sure she'd love to talk about it. Anyway, yeah, so the idea behind this was that extended reality learning environments, so like VR or AR, augmented reality learning, is getting really popular, but there's a lot of issues. They found that very often, like while they're really engaging and entertaining and students come out of it and they go, I had a great time, when they actually test to see if they learned anything, they didn't learn anything. And they're finding that there's like a lot of issues with like cognitive overload and stuff like that. And then it's just like, it's to some extent, it's like, it's almost like it's too entertaining and they're not actually learning anything. And they found in previous work that, you know, putting learning like scaffolds in helps a lot with that. So reflection is a kind of learning scaffold that's not new. It goes way back. Traditional learning, like even just in a classroom, like would have students reflect on their learning process, would reflect on their process of solving a problem to just help them kind of absorb and think about and internalize what they were doing. But in existing virtual reality and augmented reality learning environments, they don't have good ways of like eliciting reflection. Like the common practice is actually to just have students take off the headset and write something down in a notebook, which is really bad if you're trying to create an immersive experience. So we were kind of thinking about how, you know, AR, XR learning environments are not conceptually dissimilar from an escape room in the sense that they're both like these embodied kind of contexts where you have to like physically do stuff. Although when we use the term embodied in the paper, one of our reviewers got really angry about it. So we actually had to take that phrase out and use a different one. But basically, like you have to physically interact with the environment. You have to physically do stuff. And then escape rooms, they're for entertainment, but they are problem solving situations where people have to go in there and solve like problems and think through things. And like prior work has actually shown that escape rooms are good for learning and they're using them in learning. So we were like, okay, so escape rooms are kind of like XR learning environments, and escape rooms have game masters who are, you know, the kind of eyes in the sky that watch what you're doing and go like, hey, don't touch that if you're about to break the room. Or will like say, did you check the red drawer if you spent the last 20 minutes interacting with the wrong thing? So we're like, well, what if you could design reflection for an XR learning environment similar to the way a escape room game master helps the players in an escape room and gets them to like think about what they're doing? Because sometimes they will just tell you, open the red drawer, but sometimes they'll tell you something more like, where have you not looked yet? And this is more like a reflective prompt. So that was sort of the idea behind it, was like, can we learn from the best practices of escape room game masters? And can we take what they do and can we turn that into like design guidelines for reflection for XR learning environments? And that was the inspiration. So we interviewed 13 game masters that we were able to recruit, and my God, recruitment was such a challenge for this study. So many people like just didn't respond to us when like they would sign up and we would contact them to schedule an interview and then they would just never respond. I got ghosted so many times.
You got ghosted.
I got ghosted, but like not in a good way. Not in like
Psh.
Not
Actually,
Ghost mentioned.
Erica,
Yeah.
can we take a step back, because I think
Yeah, sure.
for the audience that doesn't know about the technical terms, what are we talking about when we say, what do you mean by extended reality, right? XR is extended reality, I
Yeah.
suppose. Okay, so give us an example.
Yeah, I mean, if you've ever like played a game like Beat Saber, which is like, a VR virtual reality headset video game. So like you put on this thing on your head that
Okay.
has like essentially puts a screen right in front of your eyes, but it's like designed to make it look like you're not taping a screen to your face. And the environment around you, basically, it almost like puts you in the middle of the digital environment. So it's really popular for entertainment gaming, but they've started using it in like learning contexts as well. So one of the people on the project, Eileen, she's sort of an expert on the topic of VR learning, and she did a lot of work with VR field trips, which were basically like using virtual reality. Students can go on a quote field trip to a place they could never go in real life, like the space station. You can't send a bunch of elementary schoolers to the space station. That would be absolutely hilarious if you could. So VR is like kind of great for that context.
And the sort of like quick terminology clarification here is like XR is the umbrella term,
Yeah.
and like VR is a type of XR. Augmented reality, type of XR.
Yeah.
Mixed reality, kind of XR.
To bring it back to the escape rooms, and you talk about the interventions, like for example, immersiveness, when student goes to the virtual reality environment, take off the headset, answer some question, and we test the learning. So you say that disrupts the immersion. So how about what's so special about, maybe not unique about, game masters looking at from top down and saying how that do not break the immersion?
I think there's two aspects to this. The more obvious one is like the fact that you don't have to like physically remove yourself from the environment. You don't have to take off a headset to look at a piece of paper and write something down, is like at a very basic level already helping to address the problem. But going beyond that, a lot of the game masters talked about how escape rooms have themes, like their Wild West theme. That one's really popular. Like a lot of them are Wild West themed. They're also, or they're bank heist themed, or they're like Lost City themed, like whatever. And when they're giving you input, the game masters often act like something that fits within that theme. So we had one person who said that they had worked with an escape room that had like a kind of space age, like futuristic technology theme. And the framing of the room was that the individual who was giving you input, who was just the game master, was an AI. And whenever they gave any kind of input, they pretended to be like, computerized. They pretended to be, I think they were giving all the input over a screen, but it was always like written as if it was coming from like a computer program. And they said when they were done and like the players were coming out of the room, they would always be like, "Where'd you get that AI? It's like really good." And they were like, "It's me. I'm the AI. It's just me at a keyboard." And I was like, "It means you're a good actor, I think."
Actually, a fun fact you said before, imagine if you could take students to space
Yeah.
in VR. So there's a project, I just remembered about that. There's a project called Universal, as in Uni VR AL. And it's a DRL NSF funded project from Turk, the people that we work with.
Yeah.
I'll talk about Turk when I talk about the CD for Old paper. And this is a brilliant project. This is actually a STEM educational project for neurodiverse people that are immersed in this VR space, which is actual space. At some point, I think they are on... they're exploring Europa Prime, which is one of the moons of Jupiter. And this is how they learn about, science, technology, and computational thinking as well. It's a really cool project. You should look it up.
And like this is where like things like VR are great because you cannot literally put a bunch of kids on a spaceship and send them.
You could, but...
you could, but like, I think there's...
You have a spaceship.
I think there's like,
safe.
there's a lot of issues with that. Like monetary, probably some ethical ones, safety concerns.
But Elon could, but let's not get into politics.
Yeah, like there's like an old phrase, like just because you can doesn't mean you should. Anyway, the point is, this is a great way to like let kids get up close and personal with something that otherwise feels very abstract to them. So that's like what's really great about these environments.
You mentioned about actionable guidelines and
Hmm.
things. What's your from the key topics and interest you find on the interviews?
Yeah.
Have it.
So we had like, I think we had like 12 themes that came out of it, which was like really cool stuff. And we kind of sorted them into categories based on like what they dealt with. So, like, a really common thing was progression and sort of using progress as kind of a benchmark of when people needed you to sort of chime in and help them. So it sounds super obvious, but the ways that they would like look for an indicator of like progression halting was interesting. It wasn't just, oh, they're not doing anything. Like that was one, but there was like also like being hyper aware of like, have they suddenly like shifted to a different problem, but they don't seem to be aware of the fact that they've done that? Because escape rooms usually have a bunch of parallel puzzles in them. And so, like, you're working on puzzle A, and all of a sudden you pick up something that's actually part of puzzle B, and you're trying to use it to solve puzzle A. That was like a really good indicator for them that they needed to chime in and help these people.
But I'm actually curious about what kind of, because I don't know if you talked about this already. Like, what is it that they're learning, the students? Specific math? Like, what problem are they solving?
So it depends. Like, generally speaking, like VR learning environments are being used in all sorts of contexts. It
Mhm.
seems like science and like STEM in general is like really interested in using them. I know Eileen was talking about projects that used them, like the space one we talked about. There was another one that I think was teaching like environmental science, and it took them to the South Pole to like do stuff down there. Um, in
But
the
I mean, in the
context,
context of your
yeah, yeah,
experiment.
yeah. So this particular study, this was an interview with escape room game masters who are like lurking in entertainment escape rooms. So people are not necessarily learning anything, but it's part of a larger NSF funded project that is looking into um, designing reflection for these kinds of immersive learning environments
Mhm.
by building an escape room that is supposed to help with logical problem solving.
Okay.
So it's essentially like kind of a training environment for logic puzzles and trying to help you like work through logical reasoning. But
Okay.
that particular escape room is still in the prototyping phase, so we've been playtesting it a lot, but it's not done yet.
I want to move on to your second paper
Yeah, sure.
because escape room's kind of a little slow paced. Let's move on to a little bit fast paced, which is esports. And
But you
can you
say that, but you like escape rooms, you have 1 hour to get out of there, and like when time is running out, people start rushing.
Oh
well,
yeah, I know.
start
Yeah, I know
solving
that.
faster?
I have crashed into my friends in escape rooms because we were
Yeah.
running.
Have you ever been to the Red
Fox.
Oh
Fox
yeah.
escape room?
I've done all of
Yeah.
their rooms.
Yeah. Have you solved the puzzle where you're like at the end you have to
I
steal
think-
the
Wait, I
diamond?
think
Don't-
they're
don't give it
going.
away.
We're going. Don't give it away,
Yes,
we're
I've
going-
done that room, but I think they're going to do it for a lab social in like 4 weeks.
We
so
are?
don't give anything away.
I have already
Oh,
done
okay,
the
so I
U-boat one. So
The U-boat one is so good. This is like an ad for Red Fox Escapes.
This is just an
now.
ad for Red
yeah,
Fox
if you're
games
in
now.
Boston, go to Red Fox Escapes. They're great. They're
Hell
in
yeah,
Central
man.
Square in Cambridge. The U-boat one is really, really good.
The team I was doing it with solved it in 35 minutes,
Oh,
which
wow.
was insane.
Yeah,
Oh,
that's insane.
we had like a similar time, and when the GM came in at the end, he was like, "You guys are insane. What the hell?"
So let's move on to the from slower phase escape rooms to and fast paced esports. Your second paper in Kai. Can you talk about us a little bit?
Yeah, so the second paper was the result of a really cool collaboration. So there's actually some backstory here. So I'm going to start with the sort of origin story, which is that in 2022, I went to Kai in New Orleans, which like off topic was hot as hell and rained every single day. I don't know how anyone lives down there. But I presented a paper that was sort of my first work on esports at Kai, and it was sort of on the ways that esports players kind of teach themselves over time and the challenges they face in that process and how we could build tools to help them. And after the presentation, I was approached by a professor from South Korea named Byung-Ju Lee, and he was very interested in collaborating with me. So his lab does a lot of work on performance and skill in esports, but they're very focused on like the physical elements of that, which is really cool because that's actually extremely understudied in esports in general. A lot of the work on esports that looks at skill or learning is looking at like the cognitive logical elements of it, like decision making, communication, but they're looking like at things as granular as like keyboard input and mouse control, and it's really cool work. So they were super interested in collaborating, and I was like, yeah, let's stay in touch. But I was kind of in the process of finishing up my PhD, and I was really busy, and they were really busy. So it didn't really work out at the time. And then last year in 2023, I went to 2024. I know what year it is. I went to Kai in Hawaii, and they were there again. And we were actually presenting in the same session. So I had a paper on co-regulated learning in esports, where we had like interviewed members of an esports club on how they helped each other learn. And they had a paper on, I think they had 2 papers in that session. They had a couple papers. And after the session, Byungju turned to me because we were sitting near each other, and he said, "I really need to bring you to Korea." And I was like, "Oh, I'm so glad you remembered that." And this time he reached out to me almost immediately after the conference to start talking about a potential collaboration. And it turned into a really cool project where they have a partnership with T1 Academy in South Korea, which is connected to T1, the arguably greatest League of Legends team in the world. And we were able to go in and do an observation study in the academy on how their coaches are teaching the players who attend the academy. So over the summer last year, 2 PhD students working under Byungju, Namsub, and Humbyul, they set up cameras and microphones in T1 Academy classrooms. I think we had 3 coaches who had like 4 to 5 classes a week. And so we recorded all of that. We had hours and hours of footage, audio. We also had screen recordings. Like, we recorded so much stuff. We had so much data. And they were able to triangulate and process all of it. And then last August, I went to Korea for 2 weeks, and I worked with Namsub and Humbyul to analyze all of that data. And we developed, we identified a set of themes that represent processes and actions that coaches take when they're working with these students, and sort of a framework of the coaching process. And I never said the name of the paper. It's called Crafting Champions, an observation study of esports coaching processes.
That's great. And also, you talk about the physical aspects of esports. Mouse and keyboard simple are very understudied, but also esports in general, and especially in Kai. What do you think about the slowly getting into this conference?
I actually would not say that esports are underrepresented at Kai or like slow at this point. There is a very prominent group of people in Games HCI, and some of these are really senior people doing esports research. A lot of it has focused on like toxicity,
Yep.
and sort of topics related to toxicity, like kind of like how they moderate and punish people who behave like that, or how people react to it, things like that. Some stuff on mental health. But there is actually a fair amount of esports work at this point in the Games HCI space. So at Kai or Kai Play, it's not uncommon to see like just a session or maybe 2 sessions dedicated almost entirely to esports. I will say, like, the esports learning literature is less represented in the Games HCI space, but it does exist. You see it more in other places, but I will also say that if you look at sports psychology, there is just an explosion of esports literature in sports psychology that is probably much larger than what's in the Games HCI venues. But it's definitely picking up speed. It's getting, every year there's more. There's like more, and there's also more on like more niche games, or just games other than the ones you would expect it to be on. Like, there was a point in time where I'd say like all the esports literature I saw at like Kai or Kai Play was like League of Legends, Dota 2, or StarCraft or something like that. And now you're seeing stuff from like games I've never even heard of.
It's League of Legends. It's always League of
It's
Legends.
always League of Legends.
Like, I don't know how many papers on esports are about. I think probably like 90% of papers on esports are about League of Legends, and the rest is about toxicity.
In League of Legends.
Some of them, yeah,
In
are
League of
toxicity
Legends.
in League of Legends.
Well, because it's like League of Legends is like the most toxic game. So like, I don't know, like apparently Marvel Rivals is like really not that toxic. So I guess you're not going to write a toxicity paper on that.
No.
This paper is especially interesting for me too, because I'm currently doing coaching too, and reading this paper provide me see how, especially in T1, how they approach coaching, because we are kind of close in our space and like in North America with the other people, the fellow coaches. So one thing I wanna, in our inner circle, we always say that people say that live coaching is pretty bad because you're basically backseating someone throughout the game.
Mhm.
That's the term they use. And VOD coaching we prefer to do because you can stop, you can explain why you should make decision. It's more informative and it's easier for coach to transfer that knowledge. But you, in the T1 in your paper, also there's a live coaching and VOD coaching. So what's the insights from that?
Yeah, so live coaching is kind of, I don't know if I want to say a hot topic, but it's sort of like a thing that keeps coming up over and over again in my work with esports is that there's not a lot of opportunities to learn during the game. And there's not a lot of opportunities to coach someone during the game. But in general, I have found that a lot of players felt like they needed that. Like, not necessarily in this, because we didn't interview players as part of this study, but in my past work, when I was looking at like coaching tools, an ongoing trend was just that like none of the coaching tools do anything while you're playing. And players are like, some players didn't, but a lot of players were like, if I made a really stupid decision, I want to know right there that I did that so I don't do it again. Because otherwise, I'm just going to keep doing it. And I'm going to get to the end of the game. And then the tool is going to be like, yeah, you kept diving face first into the enemy team when they were under tower. That was a bad idea. And I'm going to be like, well, why didn't you tell me that the first time I did it? So I think there is some merit to live coaching. It's also, and this is something we talk about in this paper, live coaching was less common overall in the data set compared to review. I think we called, review of gameplay. Review of gameplay was like, it was not as frequent, but it involved a lot more conversation. So we have both like the frequency and the word count. And while there were more instances of live coaching across the data set, they're so much shorter. Like it's just little things. It's like little things like, don't click that, buy that item.
So our third paper from Aubrey and is about the virtual reality. I'm glad that we explained the terms what is XR and because
What
that
is
will be
XR?
what it will come into very handy right now. So Aubrey, can you talk about your first paper and the bird?
Yeah. So Bird's a paper I've been working on for a really long time. The Bird is an interaction technique for virtual reality. It is a point cursor. So it's a one point anywhere in 3D space that you control with one hand and no controllers. It's called the Bird because it's a mouse that flies.
Okay.
I can go into the underlying math, but there's some math.
No, I like that. I mean, flying mouse doesn't sound as catchy as bird, so I like that.
Right, exactly.
What's the problem you're solving with the bird?
Yeah. It tries to do interaction in VR in a way that is more fundamentally three-dimensional. So there's this thing in VR interaction where you can do direct manipulation, which is interacting with stuff just with your hands that's within arm's reach, exactly the way that you would interact with a physical object in 3D space, which is great for things that are small and close to you. But if you're in VR, you should be able to interact with anything that you can see, because, like, you can. There's no reason to not. And so the way that we tend to do interactions in VR that are beyond arm's reach is with something called ray casting, which is a laser pointer that comes out of either your hand or a cursor usually. And the thing you run into in VR UX design, and this is, I'd like any person, yourself, any person listening to this podcast to like imagine any time you have ever put on a VR headset, if you have ever put on a VR headset, and the experience that you are imagining, if it is like 95% of VR experiences out there, is a giant screen floating in front of you that you point at with basically a laser pointer. This is like the thing that gets me most. Giovanni is laughing over in the corner. The thing that gets me about like VR UX design is that we have like put so much work into creating this like miraculous hardware where you are inside of the computer. And then once you are inside of the computer, the thing that we show you is a screen.
It's a screen inside a screen.
Yeah, exactly. Which like makes sense because like we know how to do UX for screens. Like lots of people who do UX, they've done UX for laptops and desktops and smartphones for like decades. But a lot of what Bird is trying to get at is this idea that if you're in XR, spatial computing is another term that specifically Apple used, and they never used the term XR when they introduced the Apple Vision Pro, but it's another term for XR in general. When people say spatial computing, they tend to more often mean like AR and mixed reality things and less VR things.
Well, fun fact, when our reviewer didn't like the term embodied on our escape room VR paper, we used the phrase spatial and immersive to replace it.
Yep. Yep.
Is that why didn't they like embodied? What's the?
I don't
I know that in
remember-
HCI people don't like
Oh.
embodied in general, but
I
yeah.
don't remember exactly what their comment was. And they admitted it was like a personal gripe and that we didn't actually have to like address it. But I think it was the 2AC who said it. So we were kind of like, why don't we just find a different phrase to use?
There's like a set of words to like not say in a Kai paper because they like get at reviewers. Like they just
Yeah.
cause reviewers to like hyper focus on
Be
them.
really careful with your use of the word significant.
Framework. You cannot use the word framework in
Or
a Kai
design
paper.
recommendations.
No, they want that.
They want
that.
design
They want
recommendations.
design
And if you don't
recommended.
explicitly say it, they'll go, this paper had no recommendations, insights, or takeaways for anyone else. And it's like, they were right there, but I guess I'll highlight it for you.
So, Aubrey, you mentioned that when we go into the VR environments, we will find a screen to click on, a screen. So, basically, a couple research I look into this for my paper, also for this podcast, that 3D instructions in VR spaces is not effective as 2D instructions. Why do you think is happening, this phenomena?
Yeah, for sure. I think that we know how to do 2D instructions. We have like given people information in 2D for like hundreds of years.
Yeah.
Like we had screens, and before we had screens, we had like books. 2D information delivery is like a thing that a lot of people have thought about for a long time. 3D information delivery that is not like a person in real physical space showing you how to do something, but is like mediated by a computer is pretty new. There's like a lot of really basic questions and fundamental research out there that is still left to do.
But instructions of what exactly? Generic?
Assembly, for example, in our VR training.
Yeah. Oh man.
Okay.
Yeah.
So it's easier for people to understand instructions from a 2D environment than a 3D one?
2D instruction rather than 3D. For example, if I ask you to deconstruct this MacBook, you rather have 2D instruction for the step by like IKEA.
Oh, okay. So you mean by 2D instructions, you mean like a PDF with
Yeah,
instructions?
kind of.
Like textual.
Or when
And
you
in-
put
in-
a screen in VR that shows
Yes,
someone
exactly.
an image of doing it.
Exactly.
Which is also like, because text doesn't render very well in VR. So when
Correct.
people
So
put,
instead it's like 6
textual
words and they're
instructions-
giant.
Yeah. But
Okay.
I don't know. If you asked me to like deconstruct that MacBook, I actually think I would prefer 3D guidelines. That's like the kind of thing I would like look up a video for to be like, okay, now how do I actually do this?
Plus.
Yeah.
But it's also like it's harder to make that with the tools we have right now.
Yep.
Create picture, not very hard. Create 3D animation, significantly harder.
Yeah.
Okay, with that, I want to move on to your second paper, which
Yeah.
is design flows. Can you a little bit give
Yeah.
information about that?
The second paper is Depth, which I actually want to make sure that I get the exact name of on the podcast because, like Erica, I'm really excited with having gotten away with the name. The name is There's Your Problem, Spatial Localization of Design Flaws in Virtual Reality Training Simulations. Depth is a visualization tool for VR training simulations in general. It creates these little visualizations that are voxel grids, where voxels are either red or blue, and it shows you where players who took longer to finish any individual step in the simulation spent their time. So, for example, the thing that actually, the like one graphic that inspired this paper, this is like a fun little bit of backstory on it, is I was working on a completely different project. That one's called Enthused, paper coming soon. Maybe. We'll see.
Paper coming soon, definitely.
Definitely within some number of years. So,
An undefined number of years.
we'll see. That's up to anonymous reviewers in some time.
Okay.
So I was working on a completely different paper, and I was looking at how long players take to finish training simulations. And I was basically trying to create an algorithm that will like automatically detect when players are doing things that have been correlated with other players not figuring out how to finish the thing in a particularly timely fashion to give them hints when they seem to be at some sort of a dead end, or a dead end that we've experienced before. And I needed a visualization to see if my data said what I thought it would say or if it was just going to be like total noise and garbage. And so I made this visualization that was going to show me the like scores for every voxel, the like completion times associated with the data for
Wait,
every voxel.
Scores for every voxel.
Voxels are like pixels, but 3D.
Okay.
Yeah. So I was like, I need
Yeah, I've heard it before.
Yeah. Thank you, though, for like cutting in and being like, that was a technical term. What does it mean?
I think
Exactly.
I learned it years ago when I took like a computer animation class.
Yeah.
They were like, by the way, these are called voxels.
Wait,
Yeah.
no, wait. Something is coming to mind. I think there was a video game. It was a video game that used voxels in the 90s. Is that possible? Blade Runner for
That
PC?
would make sense. There was
That's
a
a
whole patch of
movie.
time where they were a good
Yeah, but they
rendering
made a video
technique.
game too.
Oh, did they make a game?
Yeah, they made a game in the 90s, and I think at the end of the 90s. I'm not sure. I'm gonna Google it, but I think it used voxels. But sorry, go
Minecraft
ahead.
is also voxel based. That's the like
Is
obvious
it?
example for most people. Or like probably rendering wise, it's at its lowest level, not voxel based, but the way you're interacting with it, where everything is a cube, voxels.
Okay.
So I was working on this completely different project, and I needed a visualization to just see if my data said anything. So I took my data and I put it in this visualization, and I put it in the VR training simulation. And critically, I also did most of the programming for the first several years working on this particular VR training simulation. So I know the things that are wrong with it because they are things that I was there for the playtest to watch people struggle with. And I was also the programmer who was lazy and didn't fix them. So as I put this data into the training simulation, I was able to like see spots light up red, and those spots were problems with the design that I knew were there because I hadn't fixed them. And I was like, oh wow, there's your problem. My like prime example of this, the one that was like, oh, this shows us information, is there is a step in which participants do not need to use wrenches to disassemble a thing. They're supposed to just like reach around to the back of the machine and pull a hose off with their hand. But a lot of participants would pick up the closest size of wrench to the size of that hose, and then they would like try to interact with the hose with the wrenches for a long time before finally figuring out something else needs to happen because clearly this is not working. And when I put all of the data for the step into the scene, there are these like red voxels where the wrenches are. And so you can just see some people who put their hands where the wrenches are on the table take a long time to finish. And if you are the developer of this, you can go, this is because they're picking up the wrenches and they don't need them to finish the step. I should probably give them some instructions.
So it's like, as Erica said, that there's a problem A, you're trying to solve it problem B's tools.
Exactly.
Oh my god, it's an escape room.
Oh boy.
We'll get there.
It's another escape room.
Yeah, because that's the cold spray training, right?
That's the cold spray training.
I can't believe it's an escape room.
What is cold spray?
I thought you guys were teaching people how to paint submarines for the longest time, and I was wrong.
That's a paint boot.
I also thought I was teaching people how to paint submarines for the longest time.
It's apparently a method by which they effectively like particleize. I don't know if that's a word.
Particularize.
Take metal and in particle form and spray it onto things, and a molecular reaction occurs that has something to do with the temperature, the size of the particles, and something else, the speed at which they're hitting each other, that they like fuse together. And they use it to build or repair things in advanced manufacturing, like boats and planes. But if you just Google cold spray, the Wikipedia article on it literally just starts explaining the chemical reaction to you with no context.
Yeah.
I can summarize it with a very easy way. It's a metal 3D printer.
Okay.
Yeah. Yeah.
But I guess a follow-up question for Aubrey would be, why do we need to have a cold spray application in VR?
That's
Okay.
Maybe that's my.
That's actually a whole other thing.
Honestly, and this is maybe like one to trim for a different Ghostcast, but VR training simulations in general are sometimes worth it to make and sometimes not worth it to make. VR training simulations are really, really useful for things that the Stanford VR lab, the Bailenson lab, refers to as DICE, which is things that are dangerous, things that are impossible, things that are counterproductive, or things that are expensive to do in real life. And cold spray is very much DICE. Like, you are working with powdered metal that is under high pressure that you then apply heat to throw at other metal. All of the equipment involved is like $30,000. The materials involved for a single spray are hundreds to thousands of dollars. And the instructions of it are full of like, hey, don't turn this knob at this point in time because the room will fill with metal that is also gas and you'll die.
Okay.
Also, the thing can explode.
Yeah,
So it's for
exactly.
safety reason,
If you're
for the most part.
practicing how to use it in VR, at no point in time will anything actually explode. If it does, we've made a grievous error, and I don't understand how we got there. Whereas if you are like practicing using this in real life, the probability of you making a mistake is like non-zero. And if you make a mistake with it, a lot of those mistakes are very expensive or will cause you extreme bodily harm. So it is, for these types of things that are dice, really useful to be able to practice them in VR. Cold Spray was an interesting and niche sort of case because it doesn't scale well. Making a VR training simulation is really hard. The Ghostlab worked on this one for years.
Years.
Multiple years. Several people working on it all the time for multiple years. And it ended up not really being used. And had it been used for its like optimal designed for it use case, it was only going to be teaching like 50,000 people, something like that. I'm not sure I'm getting that number from, but not like millions, like relatively small. And so there is this question when you make VR training simulations, is the amount of time that is going to go into making it so much that you could have just had a human being train each person in a one-on-one, hands-on way for the whole thing. That's the math.
I'm curious, like, do you know how well the knowledge you guys taught in the VR training sim transferred? Because I got to test it out recently, and the Shripad was watching me test it, and he was like, "Wow, you're like the perfect user. You just like sped through that really fast." And I'm like, "Yeah, but I'm pretty sure if you put me in front of the real thing, it would explode."
Yeah, we had a user study, actually a couple. We tested how effective it was in learning. So we find 78% participants from they know nothing, they actually answered 4 of the 5 questions very correctly. So that was translated a lot. Knowledge translated very well. But there was a lot of thing that why we need that training. We still need more testing, especially with our target audience was engineering students, not operators going to be operating Cold Spray.
Yeah.
So we also need to get a better result. We need to test on the target audience too.
Faye was on the project too, for the audience, in case you didn't notice.
Yeah,
I didn't know.
I designed that for 3.5 years. The Aubrey was super helpful on the development and designing also. So, but that's maybe another topic.
That's maybe another episode, yeah.
So I want to move on to Dr. Scratch.
What is Dr. Scratch? So should I tell the audience about the title of the paper first?
Yeah.
Which I don't remember.
I
think it's
look it up?
CT for all. I think it should be CT for all towards putting teachers in the loop for evaluating automated computational thinking metrics for game-based learning.
That sounds familiar.
Wow, that's a mouthful. Okay, what is Dr. Scratch? Dr. Scratch is Dr. Scratch. It's a tool. It's a web-based tool that teachers and students can use to assess the computational thinking score of projects that have been created in Scratch. And if people don't know what Scratch is, well, I don't know in what world they live, but okay, I will explain to them anyways. So Scratch was created by MIT and Mitch Resnick, I think around 2009, if I am correct. And it's basically an online open source platform that kids, for the most part, or like young students can use to create mini games using block-based programming. What is block-based programming? Block-based programming is like coding, okay, like coding a software, but instead of using strings of text, as you would do in coding environments like C#, C++, Java, you use blocks that look like Lego blocks, if that makes sense. So you have blocks with different colors, and each block contains a coding, how would you call it? Procedure, right? Or something like that.
Function?
So, function.
Yeah.
For example, green blocks are for conditional statements, if, else type of thing. If I recall correctly, motion blocks are blue. And then, you have like a bunch of colors for different blocks. And each of these blocks has a coding, what did you call it?
A function?
A function, yeah, like a coding function. You can combine them together and you can create softwares. For the most part, they create games with Scratch. So Dr. Scratch, to go back to Dr. Scratch, is a web tool that is assessing the computational thinking of projects created in Scratch. And I can explain how that happens and why.
And also, before we explain, what is computational thinking?
Yeah, okay, that's a really good question. So computational thinking is a rather interesting concept because it really depends on who is talking about computational thinking. It has been debated for many years how we should define computational thinking. For example, we have definitions from Jeanette Wing, we have definitions from Dave Weintraub, Resnick and Brennan provided definitions of computational Seymour Papert. But if I have to simplify a notion of computational thinking, I would say it boils down to problem solving. And problem solving is about problem decomposition for the most part. So you have an abstract problem you're trying to solve, and to be able to solve that problem without going completely crazy, what you do is you break it down into smaller, manageable parts that you can actually manage, and then you solve the problem in a sequential fashion. So maybe that's an abstract explanation of what computational thinking is, but you can also see it as thinking in terms of computing, so thinking like a machine, or thinking in a way so that you can formulate problems that can be solved by a machine. But I can give you a pretty cool example from Mindstorms, Seymour Papert Mindstorms, when he talks about powerful ideas and the way René Descartes came to realize that we have two axes that we can use to measure distances and what do you call it, like a position, right, in real life. So you have the y and the x-axis.
Cartesian coordinates.
Cartesian coordinates, right? I mean, Descartes, Cartesian coordinates. So the way he came to realize, I mean, maybe this is a myth, this is a legend. I don't know if this is actually true, but this is what Seymour Papert says in the book, that Descartes was in bed and he was looking at the ceiling, and there was a fly that was just, I guess, bugging him. It was flying around.
The fly was bugging him.
The fly was bugging. So what he realized in that moment is that if he used mathematical thinking, he could pinpoint exactly where in space the fly was positioned at any point in time while it was moving. And he realized, well, I can calculate the distance when the fly is moving horizontally and when the fly is moving vertically. And I can call that X and Y. And I can imagine that I have a grid. And this grid is essentially points in space that I can attribute numbers to. And so I can have X1, Y3, X3, Y7 type of situation. And so basically Descartes used computational thinking to solve, or to create rather, Cartesian axis by looking at how a fly was flying on the ceiling.
Man, I wish like world-changing theories came to me when I was lying awake in bed.
Well, I mean, yeah, well, maybe maybe that's going to happen at some point.
Maybe I need a fly on my ceiling.
But so what is interesting about that is that he broke down if you think about what I just said before, right, breaking down an abstract problem into manageable steps. He broke down the abstract problem of how do I pinpoint the exact position of the fly flying on the ceiling by thinking mathematically. And he used algorithmic and procedural thinking to, create the Cartesian axis, the two numbers, the horizontal position, the vertical position.
So it's like Battleship, basically.
Yeah, kind of. Yeah,
So, okay, so in your title you mentioned the involving teachers.
Yeah.
Into this Dr. Scratch, which uses computational thinking to measure the problem solving of the students.
Basically, the Dr. Scratch metrics, what they do, they measure observable coding practices in Scratch, which means that they measure how the blocks are used when students create their, like game or software in Scratch, how they're used and what blocks are used and how many times they're used and for what purpose. And so, for example, let's say that you use if and if-else blocks, which are blocks that... What did we say before? Blocks about functions, right? Of that embed functions of logical thinking or instances of logical thinking. That speaks to one of the dimensions of computational thinking of Dr. Scratch, which is logical thinking, right? And so that's what Brennan and Resnick would define as a conceptual encounter. So you practice something that relates to logical thinking, and as you practice, which in this case you practice through coding, you encounter the concept of logical thinking. And so in Dr. Scratch, when you do that, like you use an if block, you will be given 1 point in logical thinking. And that's basic development in computational thinking. Then you have developing development, which is kind of redundant, which is 2 points. And then you have proficient development, 3 points. And in this paper, we added a new scale point, which is advanced, which is kind of like finesse. If you do something that finesse in terms of coding, you get 4 points and you are advanced in computational thinking.
Second question is that why teacher needs to be involved?
Oh, yeah. Well, I mean, because they're the ones who are, supposedly deploy and use these metrics. So the fact that they have never been involved in their design and the way that these metrics look or assess computational thinking, for that matter, that's kind of strange. It's like, well, you're designing a car, you're designing a Formula One car for a Formula One driver, but you never test.
Learned how to drive, yeah.
Yeah, like, so, and then if they don't understand how to drive the car, then it's kind of pointless, right? You're designing something that can't really be used by your end users. So, we realized we had an epiphany. You're like, wait a second, but have teachers and students ever been involved in the design of these metrics? Turns out, no, they haven't. And we were like, what? That's kind of a problem, right?
From the appearance of the problem, like teacher was not involved before, probably there were some barriers them to involve.
Yeah, well, the main barrier is that designers. That's the main barrier, because they didn't think it was, appropriate, or they didn't think it was a good idea to test with teachers or to have them in the loop of testing these metrics, which is kind of silly. And the second barrier is that for the most part, your average STEM teacher doesn't necessarily have a background in computer science or, like a computational thinking, for that matter. So they probably don't or won't be able to understand what those terms mean, like synchronization, parallelism, abstraction. And in fact, they didn't. When we did the study with them, they were like, what do you mean by parallelism? I don't know what this thing is. Can you explain? Because they didn't have a background in computer science. So I guess that was another barrier.
So to maybe providing more inclusive language or on those terms, or maybe give teachers some context about it, would think help to including these metrics into the...
That would be the next step. So one of the results of, because I'm still talking about the paper, right, I guess. So one of the results we had from, and I don't want to spoil too much because, come to Kai 2025 and come to my presentation on Monday the 28th, I believe, and you will know more about...
Where was the conference?
The conference is in Yokohama in Japan.
So buy those plane tickets right now before the prices go up further.
Yeah,
also, I think in-person registration maybe has already closed and is full.
Yeah, they like actually capped registration for the first time ever because they got so many attendees.
Like what, 5,000? They 5,000.
Like I don't think they've ever done that before, because I know in years past you could walk into Kai and just buy a ticket right there.
Man, we're gonna have 5,000 people.
So anyways, if you don't already have a ticket to Kai, you can also read the paper after.
But anyways, so I'm not gonna spoil all the results, but part of the results from the interview, we interviewed 7 teachers, STEM teachers from middle school, by the way. Part of the results was that, like I said, they didn't really understand all the technical terms because the metrics don't really provide a user-friendly explanation or comprehensive. And by virtue of that, they didn't think that their students would be able to. They were like, well, if I'm a 40-year-old adult that has, like the cognitive development of a person who's teaching at school and has been studying technically science, technology, engineering, math, and all of that, and I still don't understand these terms, how is my 12-year-old student going to understand what does it mean? Like a synchronization, parallelization, or whatever. So that's something that emerged from the results prominently, which we're going to do something about it in future work. But again, I don't want to spoil too much.
Okay.
Come to the presentation and you will know.
Also, lightning round. What are folk most excited about for their? This will be my first Kai ever, so actual real
this
question.
Would be a cool thing, yeah.
What are each of you most excited about for going to Kai? Like, what is the thing to not miss for someone who is going for the first time?
gonna have Japanese sushi in Japan for the first time. I swear, man.
Oh, right, I'm going to Kai. And then my whole brain's been like, you're going to Japan.
Okay, now maybe we should start with you because
what
this
are
is
you
your
excited
your first time.
Yeah, this will also be my first time in Japan. And I've got to say, the way I've been describing it to people is I'm like a little excited about the Japan trip, but I'm like very excited about the fact that the Japan trip is to Kai. Like Japan is there most of the time.
Only most of the time. Sometimes it's not.
One would expect Japan to be there.
Exactly.
Every now and then it just kind of it phases into a different reality.
Okay.
But don't worry, it always comes back.
Whereas like Kai is only there some of the time. Also, I didn't get a paper published in Japan. I got 2 papers published in Kai.
In Japan.
In Japan, which is different.
That wasn't clear enough,
Yeah. So I'm really, really excited about the conference. And for me, the conference like happens to be in Yokohama, which is pretty cool.
I get the impression that something you, just knowing you, might like a lot at Kai is the interactivity demos. That's like the session where you get to go and like play with everyone's cool toys that they've made. I actually I didn't pay that much attention to that in the past when I've gone to Kai, but I actually went to it last year because I was trying to kill like an hour because I was supposed to meet up with someone for dinner and I didn't have anything to do. So I went to the interactivity demo session and I was like, yeah, I'll just wander around and then I'll leave. And actually I really enjoyed it.
So Kai is really good actually for connecting with people.
Yeah.
Networking, that's brilliant.
If you're at the poster sessions, you can see those talks online after.
Yeah.
Is what I'm hearing.
But this is an opportunity for PhDs like you, Faye and Aubrey. Kai is a great opportunity to do network, with people that work in academia or in the industry. So it can be really good for your future if you plan on staying in academia or go to the industry. You can connect with people that, potentially could be your next employers.
And sometimes you'll connect with someone who will fly you to the other side of the planet for a month.
Like she did.
Yeah, I met them at Kai, and now we published together. And because it was such a successful collaboration, we're continuing. I'm going back to Korea in June for a longer visit to work on the next paper with them.
That is extremely
And that
exciting.
all started with Kai. So
What I'm always looking forward to when I go to Kai is to attend presentations of crazy papers I know that I'm probably not going to come across within the provision of the research I normally do based on the grant proposals that I'm writing or, like my specific interest in computational thinking metrics. So I really like to go if I manage, because that's what I'm warning you, Aubrey. Erica already knows, but you don't know. It's going to be really challenging. You're going to see people literally running in the corridors to try to get to the session.
and people are going to run out in the middle of sessions because there's 2 overlapping sessions and it's I want to see this paper and that paper.
Yeah.
So they're going to sit for 2 papers and then book it.
Incredible.
But that's something I'm excited about, attending presentations and seeing presentations of papers that are a little bit out of the scope of my research so that I can also broaden my scope and see interesting stuff. Like, for example, last year, I saw a brilliant paper, which was, I think it was called I Shot My Interviewer. And it was a VR.
Oh, I remember this one.
It was so cool.
Hard to forget.
It was so cool. It was basically, these people were doing interviews in VR using a gamification application where when you were tired of, being we always say you can opt out right from the interview. You can, whenever you want, you can leave if you feel uncomfortable at any point in time. So the way they were doing it in this study is that they were shooting the interviewer with a gun in VR. I don't want to be part of this interview anymore.
I'm done with this conversation.
I'm done with this conversation, man. And so that was
That's
really
amazing,
cool.
honestly.
Yeah, and you never, if you don't go to the conference, you're never going to. When the hell was I going to read that paper, anyways?
Yeah, that's not going to just come up in any of my lit reviews right now.
Yeah.
So that's what makes me really excited about going to Kai and the networking and the parties that we're gonna have on
The parties.
Wednesday, I guess.
The parties were interesting, yeah. There was this big... Well, it was funny because there was this big Northeastern party at the Hard Rock Cafe last year.
Yeah.
And it rained the whole week of Kai in Hawaii. It was... Yeah. And it wasn't constant rain. It would be fine. And then it would be a typhoon. And then it would be fine again. And we were all at the party, and it's like open to the outside to some degree. Like there's a roof, but the walls are open, and all of a sudden it is a torrential downpour outside. And I'm like, we are now trapped at the party. Like, you're not going home unless you're okay with a shower.
I think with that, we can conclude the first episode of Ghostcast.
Woo.
Rock and roll.
Rock and roll. Thank you so much for listening. I'm Faye, your host, and Aubrey, Erica, and Giovanni. Any last words? That sounds very weird.
See ya, Kai. Yeah.
Any last words?
Any last words? Oh my God.
Any
You
last-
didn't warn me. See ya, Kai. Good luck with the jet lag.
Oh yeah, good luck with